Hello and welcome to this beginner-friendly introduction to machine learning. If you have ever wondered how computers learn to recognize faces, recommend movies, or detect fraud, you are in the right place. Let's begin from the basic and build a clear understanding of what machine learning is and how it works. What is machine learning? Machine learning is a technique that allows computers to learn from data and make predictions or decisions without being explicitly programmed with specific rules. In traditional programming, we give the input, define the rules, and the machine gives the output. In machine learning, we give the input and correct output and let the computer figure out the rules by itself. It's a bit like humans learn through examples rather than being told exact instructions. Real life analogy. Let's take a simple example. Imagine a baby learning what an apple is. You show the baby a red, round fruit and say, "This is an apple." You show different types of apples: green, yellow, big, small. Eventually, the baby learns to recognize an apple even if it has never seen that exact one before. This is how machine learning works, by observing patterns. In many examples, rule-based versus learning-based. Here's a quick comparison. In rule-based systems, we define logic manually. For example, if a number is divisible by 2, it's even, otherwise it's odd. But in a learning-based system, we just give the system many numbers along with whether they are even or odd, and the machine figures out the logic behind it by itself. That's the power of learning from data. Predicting house prices. Regression. Let's try predicting something like house prices. Imagine we have this data. In 2014, the price was 2 lakhs. In 2016, it was 4 lakhs. In 2018, 6 lakhs. In 2020, 8 lakhs. If this pattern continues, what do you expect for 2022? Most likely 10 lakhs. This is a pattern the machine can learn, and this type of problem is called regression. Linear regression. Regression is used when we want to predict continuous values like prices, age, or temperature. In linear regression, the machine fits a straight line through the data like a graph using a formula y equal mx plus c, where x is the input like year, y is the predicted output like price, m and c are learned from the data. Classification example. Now let's look at another common task, classification. Suppose we have a light sensor. We measure brightness and label it as either high or low. When new light levels come in, say 70 or 90, the machine classifies them into 1, of these categories. This is called binary classification because there are only two possible outcomes. Logistic regressions. To perform classification, one common algorithm is logistic regression. Although the name says regression, it's actually used for classification. It outputs a probability. For example, a value between 0 and 1, based on a cutoff like 0.5, it decides whether the inputs belongs to class A or class B. Multi-class classification. Sometimes we have more than two categories. For example, classifying cars based on number of seats, 2 seats coupe, 5 seats sedan, 7 seat SUV. This is called multi-class classification, and the machine learns from examples to assign the correct level. Supervised learning. When we train a model using data that includes both inputs and the correct outputs, it is called supervised learning. It's like a teacher providing both the question and the answer. The model learns the pattern and tries to give the right answer for new questions. Regression and classification both fall under supervised learning. Unsupervised learning. But what if we don't have any labels, just the input data? In that case, we use unsupervised learning. Here, the machine tries to find hidden patterns like grouping or structure. A common technique is clustering. Clustering example. Let's say we are analyzing customer shopping behavior. Some customers buy milk and bread, others buy chips and soda, another group buys eggs and cheese. The machine automatically finds groups of similar shoppers even though we never labeled the data. This is how recommendation engines work, by finding patterns in user behavior. Anomaly detection. Unsupervised learning can also be used for anomaly detection. For example, your credit card is used in your city and then just a minute later in another country. That's a red flag. Anomaly detection spots unusual or unexpected activity, and it's widely used in fraud prevention. Reinforcement learning. Now let's talk about reinforcement learning, a different type of learning. Imagine a child learning to ride a bicycle, then try pedaling, balancing and turning. If they fall, that's negative feedback. If they ride smoothly, that's positive feedback. Machines can learn this way too. They take actions, receive rewards or penalties, and learn which actions lead to success. Reinforcement learning is used in game playing AIs, robotics, and self-driving cars. Training and testing the model. We building a machine learning model. We dive the data into two parts: training data and testing data. Training data used to teach the model, and testing data used to evaluate how well it learned. It's like studying from a textbook, then taking a test to see if you really understood the material. Sometimes we also use a third portion called a validation set to fine-tune the model before the final test. Key terms. Let's go over a few important terms. Feature. The input variable like year, age, height, level. The output you want to predict like price or category. Model. The function the machine learns. Training. The process of learning from data. Prediction. The model's output for new, unseen data. Evaluation. Checking how accurate the predictions are. Types of machine learning. Let's summarize the main types of machine learning. Number 1, supervised learning learns from labeled data used for regression and classification. Number 2, unsupervised learning finds hidden patterns in unlabeled data used for clustering and anomaly detection. Number 3, reinforcement learning learns from feedback and rewards common in gaming, robotics and simulations. Real-life applications. Machine learning is already part of our everyday life. Here are some examples. Voice assistants like Siri or Google Assistant, product recommendations on Amazon and Netflix, spam detection in email, credit card, fraud detection, self-driving cars, face recognition, language translation, predicting stock trends. The applications are endless. Final thoughts. Machine learning is not magic. It's math, data, and logic. The more examples we give the machine, the better it gets at finding patterns and making decisions. This was just the beginning of your machine learning journey. As you explore more, you will dive into algorithms, model tuning, neural networks, and real-world projects. Keep learning, stay curious, and welcome to the world of machine learning. Thank you for watching. If you found this video helpful, don't forget to like it, share it with your friends, and subscribe for more simple and powerful tech explanations. Your support helps me bring more content like this.